Binomial theorem. We are now going to look at expanding brackets using a thing called binomial expansions. At the start of this topic, you were asked how easy you would find it to expand these. Well, you found you had to use a multiplication grid and it was very onerous, so now I'm going to show you a different technique. So by the end of this lesson, you should be able to achieve this goal in a far more efficient way. Recall at the start we expanded these, so x squared plus 2xy plus y squared was what you had when you expanded a square bracket, which you know, and then we used that with a multiplication grid to do that. Well, there's actually a connection between the Pascal triangle you did in the last exercise and expanding brackets, and that's what we're going to look at today. X plus y squared, all squared, has coefficients 1, 2, and 1. Now, if you actually consider that's to the power of 2 in the bracket, it actually belongs to a connection between row 2, and you'll see 1, 2, 1 appear here. X plus y to the 4, we've already got the expansion answer for it, and the coefficients are 1. I'll just show you here. The coefficients are 1, 4, 6, 4, and 1. Well, let's have a look at your Pascal's triangle. So you know that the 1 and the 1 make 2, and the 1 and the 2 make 3. So let's look at the 4th row. 1 and 3 make 4. Remember, the first term's always 1, the last term's always 1. 1 and 3 make 4, 3 and 3 make 6, 1 and 3 make 4. Look, it's the same numbers. So there's a connection there. There's also a connection to do with powers as well. So let's have a look. Anything to the power of 0 is 1. So what you'll find is row 0 has always got a 1, okay? X plus y to the 1, you wouldn't normally have a bracket there, you would just say x plus y. So you've got 1x and 1y. Look, 1 and 1. And x plus y squared we've already dealt with, and we've looked at with 1, 2, 1, and with the 4 we've looked at the 1, 4, 6, 4, 1. So in that case, how on earth could we get x plus y to the 3? Well, we need to consider other parts of it. So let's look at your expansion of x plus y to the 4 and focus on this term. Remember, this would be 4, 0. This would be 4, 1, 4, 2, 4, 3, 4, 4. Okay? Remember, 4, 0 and 4, 4 always give you the ones out from Pascal's triangle. 4, 1 gave you the 4 out, but what about the powers? Well, look at that. X to the 4, x to the 3, x squared, x, and then x would be to the power of 0. There is no y, so it could be y to the 0, y to the 1, y to the 2, y to the 3. So 4x cubed y could be written as 4, 1, and then 4 take 1 would give you the 3. Oh, look at these numbers here. And then y is to the power of 1. So there's a connection between these digits and in here. So let's now go over here. There is no x there. It doesn't mean that x equals 0, because then it would disappear. It means it's x to the power of 0. So we know that is the term 4, 4. The binomial coefficient is 4, 4. And then how do you get rid of the x? It will be 4 take 4, so it becomes x to the 0, and the y is the 4. Look at this, 4, 1, 4, 1, 4, 4, 4, 4, and then the 1 and the 4. So there is a connection between the numbers here, and you'll find the top number is always what the power is. So the general term is actually of this format, where whatever your power is will go here, and whatever part you're looking at will be the r. So if I was looking at 4, 1, it'd be 4, 1, and then 4 take 1. And then if it was 4, 1, the 1 would go there, okay? So let's have a look at these brackets again and see if we can do x plus y to the 3. So we know it's 1, we know it's 1, 1, we know it's 1, 2, 1, and look, x squared x to the 0. And then we have the x4, x3, x2, x1, x0. So what about x plus y cubed? We should have 1, 3, 3, 1 as the numbers at the front. And because it's 3, it should start with, look, that's x to the 1, x to the 2, x to the 4. It should be x to the 3, x to the 2, x, and y. Okay, so that's y0, y1, y2, y3. This is actually in your formula sheet. It's the binomial expansion, and what the sigma sign means is we're going to add all the terms from 0 up to n. So n0, n1, n2 up to nn. And this tells us to start with the larger power and then reduce the first term, whereas increase the second. You will also notice, especially here, that the two terms always add to the full power of n. They always add to the full power of n. So we're going to explore using both of these formula. Right, so if I asked you to expand x plus y to 3 this way now, what it means is I'm going to add 3, 0, 3, 1, 3, 2, 3, 3. And then after that, I'll have x, and it will start with 3, and it will be x with 3 take 0, 3 take 1, 3 take 2, 3 take 3. I wouldn't write that, I would just find a number. And then y would start with, if you start with 0, that will be a 0 there, the 1 will be a 1 there, the 2 will be a 2 there, and the 3 will be a 3 there. So what do we have? We also know Pascal's triangle has 1, 3, 3, 1, so we know the coefficients will be 1, 3, 3, and 1. That will become x cubed, and that is just times 1, or y to the 0 if you want. Okay, x squared, x1, x0, and then y0, y1, y2, y3. Okay. We know that anything to the power of 0 is 1, so finally what we do is we smarten it up. Okay, let's do one more and then you can try. So x plus y to the 5, I know it means I'm going between 0 and 5, and I'm starting with the x because it's the first term, and then the y. So what do? You do 5, 0, 5, 1, 5, 2, 5, 3. You can put x in, or you could go x5, x4, x3, x2, x1, x0, and then y0, y1, y2, y3, y4, y5. And what you'll notice is each time the total of the powers is 5 because it was to the 5. Okay, let's use the triangle then. So we know that goes 1, 3, 3, 1, and then it's 1, 4, 6, 4, 1, and then 1, 5, 10, 10, 5, 1. It should appear. So that means we can put the coefficient down. We know that will be x to the 5 and the y will go to 1. We know that that will be x to the 4y. So we don't need to write to the power of there. And we know that's x cubed y squared y cubed, xy to the 4. And lastly, we have y to the 5 because x to the 0 is 1. And all you do after that is write it without all the brackets and bring it together. It's nice, isn't it? Okay, in that case, you can go to Scholar Unit 1, page 14 and try these, or just use the PDF or freeze the video just now. Your answer's in 238. What I'm going to do is a second video with tougher ones. So if you want to keep these and do all of the questions at the same time, then watch the next video. But I think it might be beneficial for you to stop just now and have a go at these first, and then we'll go on. So what I recommend, you can see you've got to go to the 9, is just draw one Pascal's triangle to 9 and then use it for all of these. Okay, enjoy.